This video will answer the question, what is div? So what is the divergence? Let's look at some examples. As a first example, let's consider this vector field. This vector field we can see has vectors all pointing in the same direction. At every single point, we have a strength of 1 in the x direction and a strength of 2 in the y direction. This vector field is constant. It is no surprise then that the divergence of this vector field is 0, as derivatives of constants are 0. So recall the divergence of a vector field. We look at components and we take derivatives in that direction. Look at the second component that's providing information in the y direction, take a derivative in that direction, and we come up with 0 plus 0 is 0. Here's another vector field. Negative y, comma, x. So if you pick a point on the x-axis, the y-coordinate is 0. In the x direction, you have 0 strength along the y-axis. Likewise, if you pick a point on the y-axis, x is set equal to 0. And so there, that vector field has 0 strength in the y direction. In the first quadrant, both x's and y's are positive valued, but we're using the opposite of the y coordinate to find the strength in the x direction. Very good. So here we have the picture of the vector field, and when we take the divergence of this particular vector field, we again get 0. So there's something that these two vector fields have in common by their divergence both being 0. All right, let's look at another example. In the third example, our vector field is negative x, comma, negative y. And in this picture, we have that all of the vectors, no matter where we pick our point, the vector is directed in towards a fixed location, the origin. If we go back and we look at the very first example, the vector field is always pointing in one direction, one fixed direction. In this example here, the vector field is always pointing inwards. And in this case, we find that the vector field does not have a 0 divergence. It has a non-zero divergence. And this corresponds with the amount that is flowing into an enclosed region. All of the arrows pointing inwards means that you have quantity being brought into this enclosed region. Versus if you look at this first picture, if you take an enclosed region, the amount that is coming in and the amount that is going out cancel out. Hence, the divergence is 0. All right. So hopefully that is giving us some intuition as to what divergence is. Excellent.